So we're at week 5, and it says, dear students, this week we'll be looking at calculating volumes of different solids. Okay, you may also come across the word surface area. Surface area is the area of each face of the solid. With solids, you will hear terms like face, edges, and vertices. Okay, and not all solids have faces, edges and vertices, right? Those are the sharp points of a solid. And not all solids have that. Some just have a face, like a sphere, right? And if you see over here, that's a sphere. And this is anybody know? It's not a cube.
It's a rectangular prism.
Rectangular prism, very good. And so you guys should know what that is. That's a triangular prism. Welcome to everybody joining. Glad you guys can participate this week. Last week we got a little break from math, but we're right back in it. Here we have a cone, and here we have a cylinder. And I've had experience trying to play videos, and students saying they don't hear the video. So let's just test it out with you guys, and you tell me what you experience, okay? So I'm gonna go ahead and test out this video here. How is that? Is that loud? Did you hear what he said?
No, sir, I'm not able to hear.
Okay, well, so every system has like a its own shortcomings, right? Its own faults or weaknesses, and it says that I can share my Google page with you, but you're not really hearing the video. And so let's look at what he's saying here. He's saying there's something called one-dimensional, right? And that's a length, that's a line. And we know that 0 dimensions would be considered a point. A point would have 0 dimensions. I think we mentioned this, we discussed this idea already. Oh, and by the way, the reason you don't see my video is because my camera is not working, okay? So that's the reason you're not gonna be seeing the video. I may use the other computer that has the video, but at the same time, that would probably be only for the when we have our parent-teacher meeting, right? That's going to be October 4th at 7 o'clock, I believe. So let your parents know about that, right? And I'll put up reminders in the homeroom about that meeting that's coming up, where we discuss certain things about how things have been going and where we're heading. But yeah, back to this lesson. You see here we have a length. It's a line segment. It's a length, and it represents 1 dimension. Here we have 2 dimensions. So we have, in this case, they're both the same, but length and width would be 2 dimensions, okay? So 2 dimensions, length and width. In this case, the length is equal to the width, okay? So we have a square. If we continue, we go into something more interesting called 3 dimensions, where we have length, width, and height. So 3 dimensions. So we've gone through 0 dimensions with a point, 1 dimension with a length, 2 dimensions with an area, and now we have 3 dimensions with a volume. And so the key to figuring out how to solve a volume problem, guys, is just find the area of the solid and then multiply that answer you get by the length. Okay, that's the secret. And this video is on your Moodle page, so you can always go back and check it out. Right, so that's area, and then we have volume here. So let's see. Whoa, let's go back. So you notice the volume gets a cube while the area is a square. Okay, so we're looking at squared for area, and for volume, you're cubing your results when it comes to your unit of measurement. Okay, because in the area we're dealing with little squares. How many squares are in this shape here? And that's what we're looking at. How many square units, how many square centimeters are in here? In this shape over here, we're actually saying how many cubes are in this solid here? How many cubes are here? And then that's what we're interested in. And then the answer is our volume. So what we're saying, how many cubic centimeters are in here, right? So we just imagine a lot of tiny little cubes that fill up the entire region or space that's conformed or put within this shape. Okay, guys? And that's basically how we look at area and volume. Okay? And so we continue. Let's see. Oh, okay, so he's showing us some. Let's look at what he got here. Got circles, triangle. Hey, what's this called? What's that shape down there called? Anybody know? That's from week 3. Week 3's assignment with measurement. Who remember? Trapezium. Very good. All right, so we have these shapes here. Now I want you to imagine that these shapes are actually just pieces of a solid. They're just a slice of the solid. So if you were like a 2-dimensional object, let's say you were stuck on a piece of paper and a sphere passed through your world, would you see a ball if you were a 2-dimensional object? Would you see that ball passing through your world? What would you see passing through your world if you were a 2-dimensional object? Anybody have an idea? If you were stuck on a piece of paper and you moved around in a 2-dimensional world and you had this 3-dimensional thing passing through your world, what would you see? Would you see a 3-dimensional object or a 2-dimensional object? Anybody? You would see two. Yeah, you would see 2 dimensions because that's the limit that you can see. That's as far as you can see. And you know what? When you look in your 2-dimensional world, all you would see would be this circle passing. It would be getting, first it would start very small because you know that's how the first part of the ball passing, touching your planet, touching your world, you would see a little dot. And then as the ball passed through your world, your piece of paper, it would get wider and wider until it reaches the part of the sphere that would be the largest portion of the sphere, and then it would start to shrink again into a dot. That's when it had absolutely passed through your world. Okay, so that's a little idea you can think about. There is actually a book that was written many years ago called Flatland, and it had that idea in it. So if you love to read and you want to read something related to mathematics that's actually like a fictional story, look up the book called Flatland. All right, something you can check out. All right, so here we got he's presenting some related solids. Okay. And for those who are entering the meeting and wondering, why am I talking through this video? It's because the video doesn't, the sound is not being heard clearly. All right, so here we've seen, how would we find the area of that? Well, we use a lot of little squares and approximate the circle. The smaller the squares, the more closely we can get to the area of the circle. The same idea works for the cube. It works for the sphere. You use a lot of tiny cubes, and the more smaller you make the cubes, the more accurate you'll get in determining the volume of this solid. And there's the example here where he used more, he decreased the size of the squares to make an approximation. So guys, in mathematics, we are just approximating reality. This is reality. You see circles, you look up in the sky, you see the moon, you see the sun, and you see these shapes, and you know about these solids. But mathematically, we can only approximate to find the actual volume of something. So we can't really tell you exactly what the volume of this is, but we can get close. And as you know, your calculator could only go so far. It can say, oh, the volume of this is 250.587325, and it can go on and on and on, centimeters cube. So that's the limitation that mathematics has, but that's just the reality of our world. We can't really tell you the definite answers for everything, right? There is a mystery to all things, right? There's a mystery. So notice here, you're getting closer. If I make those very, very tiny, it will look exactly like this, or very close to that. Okay, so it's a very interesting video. I would hope that you would take a look at it. Let's see here. That's the triangular prism. So there we get the idea of what we're doing. So if you find the area of this triangle here, then you could just multiply it by the length and you would get the volume of this entire shape. Okay? That's the concept of volume. Any questions so far as I've been skimming through this video?
No, sir.
No? Okay. So the concept, remember I told you the trick to beating these kind of problems, look for the area, solve the area, then multiply it by the extension, which could be a height or a length. Well, let's see if they give the formula for the sphere. No? Okay, let's see how he extends the sphere. Okay, so you're seeing the different ideas people have had to try understand reality, right? These are ideas that are almost 3,000 years old that you're learning right now. All right. There was a guy named Euclid that studied these things. So these are very ancient. This is very ancient mathematics that you're learning, but it's still relevant 3,000 years later. Okay. So I think this would be nice to screenshot. Let's get the next formula too. There we go. Let's see. No, I got the whole thing. Right. There we go. So get a screenshot of that because this will probably come up in your assignment. You're going to be finding the volume of shapes in your assignment, and you're going to probably need to know these formulas. They're not as, what would you say, self-evident, where you can just look at it and say, oh, okay, yeah, I know this is a circle times the length. Oh boy, but it's not really a cylinder, is it? It's truncated. It's lost some of the cylinder. So it's a cylinder that's been, it's been affected in some kind of way. And because of that, we have this formula. And there are ways to derive this formula, but I would encourage you to research, how do you find this formula? I would encourage you to look for videos that would show you how to get this formula. How did they get this formula? Right? That's a mathematician. Curiosity. Be curious about how they figure that out. And then you can find out how all these formulas came about. It's not just by accident.